Hello everyone and welcome to Mathssteps. In this lesson we are going to learn about negative indices. So how can we find the answer to two terms which have same base but negative indices. The terms might have same letters but might have numbers as well. So there might be a mixture of letters and numbers. So how are I going to do that one? So let's have a look at these questions that I put on the left-hand side. Can you see? So I've written down the answer already to the first ones. So remember 2 to the power of 1 is 2 and 2 to the power of 0. Now remember something, every number to the power of 0 is 1. Now 2 to the power of minus 1 is 1/2. Remember 2 to the power of minus 2 is 1/4, 2 to the power of minus 3 is 1/8, and 2 to the power of minus 4 is 1/16. Now when you have a letter or a number 2 to the power of a negative power, right? So what you do is, for example, let's take 2 to the power of minus 2. This is the same as 1 over 2 to the power of 2. 2 to the power of 2. So pop this into the denominator with positive indices. And the answer is going to be 1 to the power of 4. So just like that. Same for every single question. There you go. Okay, so this is the general rule. So a letter or a term with the same base to the negative indices, it is same as 1 over that same base with the positive indices. Right, and power of 0, any number, any term, any number, any letter to the power of 0, it is always 1. So for example, this case, 2 to the power of 0 is 1, a to the power of 0 is 1, or b to the power of 0 is 1. Every single term, every letter, it is going to be, so if it's to the power of 0, so the answer is going to be 1. Okay, now how about 6 to the power of minus 2? So straight away, this is the same as 1 over 6 to the power of 2. All right, just like that. Leave it like that. Or if the question says find the answer, then it goes. So you can do it like that, 1 to the power of 36. It depends what the question says. But usually when you work with indices, the question is not going to ask you to do the division 1 divided by 36. Usually they will ask you to leave it to the power, as expressed as a term to the power of something. 7 to the power of minus 3, of course, pop it into the denominator, and this is 1 over 7 to the power of 3. And then here, now, we have a number and a letter to the power of minus 4. Now, just the letter is to the power of minus 4, not the number. Okay, and that means you leave the number as it is. So 9m to the power of minus 4 is the same as 9 times m to the power of minus 4. And m to the power of minus 4 is the same as 1 over m to the power of 4. Okay, can you see? So 1 over m to the power of 4 actually is this one, just this bit here. Now this form, 9 times 1 over m to the power of 4 is the same as 9 over m to the power of 4. So you can put this 9 in the numerator and means exactly the same thing. Next question, there you go. The question found there. Now, okay, next one, 9 to the power of minus 6. The answer is going to be 1 over 9 to the power of 6. Next one, 11 to the power of minus 5 is the same as 1 over 11 to the power of 5. And this one is going to be the same as 1 over 24 to the power of 90. So remember this rule, because this rule is widely used when you simplify algebraic fractions. And 8 to the power of minus 2, of course, is the same as 1 over 8 to the power of 2. And I'm going to let you do E and F. I'm going to let you do E and F independently. Now here we have numbers and letters. As I said previously, 10 is not to the power of minus 5, just G, just a letter. So this one becomes 10 goes into the numerator over G to the power of 5, because G to the power of minus 5 is the same as 1 over G to the power of 5. So this is a quick use of simplification of this term here. And this one it is 3 over h to the power of 8. This one is going to be 13 over I to the power of 10. Right? Let's have a look at the answers. Here you have all the answers on the right-hand side. Right, so, okay, next. Now here you have a little revision of what you learned so far. You have multiplication of same base terms and power of the power here. Here you have terms that include letters, same letters, can you see, and numbers as well. So as I said before, multiply the numbers and then multiply the letters. And here, what you do the numerator first, so use the rule of multiplying, which is 9 plus 6, it's 15, so 3 to the power of 16 to the power of 15 divided by 3 to the power of 5, or you can go for simplification straight away. So there are different ways. So for example, if you express it 3 to the power of 6 as 3 to the power of 5 times 3, right? You can go for the simplification just like that. And then you have 3 to the power of 9 times 3 to the power of 1. And the answer is going to be 3 to the power of 10. Or go for multiplying the top, 3 to the power of 15, divided by 3 to the power of 5, and the answer is still going to be 3 to the power of 10. Here, again, multiply the top, multiply the bottom, and then use the rule of division. Or go for any simplification if you can, by expressing, for example, 11 to the power of 6. Express this because I can see to the power of 2 to the power of 3. So I'm going to express this one as 11 to the power of 2 times 11 to the power of 3 times 11. I'm going to put 11 to the power of 1, just to make you understand where 6 goes. So 2 plus 3 plus 1 to the power of 6. And then I can simplify straight away to the power of 2's to the power of 3's. Then I'm going to be left with 11 to the power of 6 times 11 to the power of 1, adding the powers, and the answer becomes 11 to the power of 7. So you can go for this one. Or straight away, do the multiplication with the rule of multiplication for the numerator, the rule of multiplication for the denominator. So the top becomes 11 to the power of 12, divided by 11 to the power of 5, and the answer is 11 to the power of 7, and so on. So yeah, thank you very much for watching Mathssteps, and have a lovely day. Bye-bye.